Hi guys, Dr. Diaz here again. Let's try to finish the last integral. This one that we have here. Right, remember this one? Yeah. This integral. Here we go. We just write it here. Integral of x of 3 to the x squared dx. Alright, good. Perfect. How we solve this one? You see this x, 3 to the x squared? There's a way we should do something like this. This is the same way we use the same approach we used with the integral. This one we used a moment ago. And if you remember in that occasion, e to the natural log of f of x is equal to f of x. Or natural log of e to the f of x is equal to f of x, because natural log and e are inverse function. So in this case, the way we're going to rearrange this 3x squared is we're going to write this in a format that it looks like e to the natural log of 3 to the x squared. Why is that? Because if 3 to the x squared, suppose, let's say this, let's say that f of x is equal to 3 to the x squared, then we can apply this. E to the natural log of f of x is equal to f of x, right? Yeah, sure, that's where we're coming from. And we want it this way because the integral that is e to the du is much easier to solve. This is always going to be what? E to the u plus c. And that's what we want. You know, make this reduce the complicated integral into one that we can manage into. So, using this thing, I will going to change something slightly. This x, to make it better, this x squared, by using the exponential rule and logarithmics, we can put it here in front of this thing, and this will be the same as e x squared natural log of 3. Perfect. And this is exactly the equation that I want. So now this equation here, this 3x to the x squared is going to be now what? This thing here, right? So now let's go with this integral. So we have integral of x 3 to the x squared dx. This is the same as the integral of e to the x squared natural log of 3 dx. Now, oh well, I'm missing something. I'm missing the x. Sorry about that. X e to the natural log. Let's rewrite it here so it makes more sense. X e to the x squared natural log of 3 dx. And here now we use integration by substitution. Let u be equal to x squared natural log of 3. Then the u is going to be, what's the derivative of this? It's going to be 2x natural log of 3 dx. Now, here we have the x and the dx, right? Let's put it here. Here we have the x and the dx, right? Because this one is going to be e to the u. So we have the 3x to the x here. We have the x and the dx, but we have a 2 natural log of 3 there. Well, we send it to the other side. Then we will have what? The u divided by 2 natural log of 3 is equal to x dx. And now each component is represented here. The u and the du. So going back to this equation now, by using the u substitution, this is going to look something like the integral. Oh, who is u? So one we're calling e to the u times, who is the u? The u is 1 over 2 natural log of 3 du. So let's arrange this one a little bit. Let's take out the natural log, the 2 natural log outside. Let me roll this a little bit down. We're going to take this 2 natural log of 3 out of the integral. We will have what? 1 over 2 natural log of 3 integral of u du. Right? And what's the integral of u du? Well, the integral of u du is e to the u plus c. Put here simple integral. So this one is going to be what? This is going to be 1 over 2 natural log of 3 e to the u plus c. But because we already said that u is equal to what? X squared, since u is equal to x squared natural log of 3, then we put here back this in, and we have what? 1 over 2 natural log of 3 e to the x squared natural log of 3. Yeah, plus c. I forgot the c. But yeah, I mean, this is his integral. But you might say, hey, the integral has a 3 to the x squared, no x squared this thing. Oh, but now we check this. Look here, this a to the x squared natural log of 3. What we can do is we take this x squared, we put it here in the 3 as an exponent. So this is the same as e natural log of 3 to the x squared. And if you remember a moment ago, you scroll up a little bit. Here, this one, e to the natural log f of x is equal to f of x, or in this case, e to the natural log of 3 to the x squared is equal to 3x squared. So this thing is none other than what? 3x squared. So the integral of x, 3 to the x squared dx is equal to 3 to the x squared divided by 2 natural log of 3 plus c. Okay, this one, actually, this is supposed to be 3 to the x squared. I'm sorry about that. That was a typo. But here it is. That's the integral. Now let me do another one, a little bit slightly more complicated. See you in a second. Okay, guys, let's try to solve this one. And this one is one of those complicated integrals that you have to do it integration by parts, and then it has a little twist at the end. So the first thing we're going to do is, you remember ILATE? Is inverse, logarithmic, algebraic, trigonometric, and exponential, or exponent, or e. In this case, well, the trig and e, you can interchange this thing. And I remember I told you guys that, sometimes it's much easier to use e to the x when e to the x has like a constant there, like a 2 or 3 or whatever, because it makes it a little bit slightly easier to do it. So let's choose that one. The way I'm going to solve this one, I'm going to say first, let u be equal to e to the x. Du is equal to e to the x dx. dv is going to be equal to what? Sine of x dx. So v is going to be equal to what? Minus cosine of x. Add plus c, that's okay. Now, the integral we're working here, the technique we're using here is integration by parts. And if you remember, when you have the integral that looks like u dv, this is the same as uv minus v du. Okay, so then here we go with this integral. E to the x sine of x dx is equal to, who is u? We select u as e to the x. And who is v? It's minus cosine. So we can put here, let's put the minus sign here, because there's a minus sign by cosine. Is going to be e to the x cosine of x minus the integral of who is v. v is negative cosine of x, and du is e to the x dx, right? So if we arrange this one again, let's put here minus e to the x cosine of x plus, because this minus sign and this minus sign cancel, it's going to be e to the x cosine of x dx. Well, this one doesn't look like this one, so that twist that we did in that problem is not going to happen now, but it will. And what happened, again, we have another integral that the only way to solve this one will be by using integration by parts, right? Okay, so who are we going to choose here, our u? Well, let's say let u be equal to e to the x, du is equal to ex dx, dv is equal to what? Cosine of x dx, and v is equal to sine of x. Perfect. And now we go here. We keep going this part here. This is equal to, let's rewrite this. It's going to be minus e to the x cosine of x. We have minus is going to be plus, right? Plus. And now we go. We're solving this integral. We got it here u. We're going to use u dv, v du. The same expression we use for the integration by parts. This one here, we're going to use it again. And we select who is u and who is v. Who is u? U is e to the x. Times who is v? V is sine of x. minus the integral, or who is v? We know is sine of x. And who is du? It's e to the x dx. And you start saying, hey, wait a minute, didn't we start with this one a moment ago? Let's rewrite it again. So this one's going to look like minus e x cosine of x plus e to the x sine of x minus the integral of e to the x sine of x dx. And yes, because if you go here, the integral we were solving here is what? E to the x sine of x dx. This integral and this integral are the same. Wow! So the only thing we have to do is we take this integral and we send it to the other side. Let me roll it a little bit. Sending this integration to the other side, we will have what? E to the x sine of x dx plus e to the x sine of x dx equal to minus e x cosine of x plus e x sine of x. Now here you take as a common factor, well, when you add those two, it's going to be 2. 2 integral, no common factor is 2. E to the x sine of x dx is equal to minus e to the x cosine of x plus e to the x sine of x. Then we divide by 2. Oh, we have to add the plus c. Then we divide it by 2 and we will get what? E to the x sine of x dx is equal to 1/2. What will be minus 1/2 e to the x cosine of x plus 1/2 e to the x sine of x plus e. Yeah, and that's it. That's it. That's the solution for this integral. Okay, guys, I hope this helped a little bit. See you next time.